All right, this is still part of section 1.6. This is transformations of trig graphs. So I'm just going to give you a formula right now. So the magic formula is all right, so this is a preliminary one. I'm going to give you a better one later. This is in general. Transformations look like this. You might have an a out front of your function, and then you might have a b inside the function multiplying your x plus a c, and then you might have a d at the end. Can you tell me what the different functions of a, b, c, and d are? So if one of them is a vertical shift, one is a horizontal shift.
D is a vertical shift.
One is a horizontal stretch or shrink, and one is a vertical stretch or shrink. Let's match them up. All right, so Evie, you had one. What did you say?
D is a vertical shift.
Vertical shift happens because of D. Marta, were you swatting at a fly, or did you want to guess one? Horizontal shift is C. Yvette, did you want to do one? A is vertical stretch or shrink. And then Tim, do you want to say which one is horizontal stretch or shrink? Yeah, that's right. Okay, so that's in general. That's for any function. But instead of f, we're going to use sine just as an example. So this is transformations of a general function. This is transformations of a sine function. So a general sine function is called a sinusoid. Okay, I changed a couple of things around because of the nature of sine functions. I'm going to upgrade my general function up here to, I'm going to say x minus c up here for my general function. And why do I do that? Sophia, can you not be on your computer, please? What does a larger d value do to my vertical shift? No, I just mean for d, for my vertical shift in my general function. What does a larger number do? It moves what? Yeah, further what? What direction? Did you say right? Did somebody say right? This is not a left-right thing. Vertical shift means up-down. So a larger D moves it up, a smaller D moves it down. What about C? What does a larger value for C do if I write it this way?
Left.
A larger value for C moves it
Oh, right.
right.
Yeah.
So if I left it as plus, it would be opposite. So leaving it as plus is counterintuitive, so it's, in my opinion, it's better to, like, this is not wrong to write it this way with a plus, but it's confusing because a larger C moves it left, a smaller C moves it right. If I write it this way, if I write it with minus, then as long as the minus is in there, then a larger C moves it right, smaller C moves it left. So I'm gonna leave my minus C down here for that same reason. That's just true in general. But this 2 pi over b is for a reason specific to sinusoids. So I'm going to define these as being absolute value of a is amplitude with a D. Absolute value of b is the what?
The period.
It's period. And it's like by decorating my function properly, I can say C is my what kind of shift? Is my horizontal shift. And D is what? Is vertical shift. And that way I don't have to convert anything. I just get I get the period B out of it for free. So I'm gonna switch over to Wolfram Alpha, and we're gonna make sliders. Not Wolfram Alpha, Desmos. And we're going to make sliders. So I'm just going to say, instead of f of x, I'm going to say y because they're synonymous. And I'm going to have a slider for a times my sine function. And then I'm going to, inside the parentheses, I'm going to say, inside the first parentheses, I'm going to say 2 pi divided by slider B then I'm going to say x minus c, and then outside the parentheses I'm going to say plus d. I'm going to add sliders for all of them. So if I move my A slider, what are we expecting it to do? The amplitude is going to get affected. So let's do a bigger amplitude, smaller amplitude, amplitude 0, negative amplitude. Okay, so A affects my amplitude. Put that back. What are we expecting B to do? What does that mean?
How often it goes up?
So it's like the wavelength, right? So if you think about this as being a sound wave, I'm gonna affect the period of the wavelength. So that's my period. So what's the period of this wavelength? It's 2. You just read it off as straight 2. That's why we put it 2 pi over b, is because we're like doing that calculation ahead of time. So b is just the period now. 2 is the period. What happens with c? What happens with that if I move my slider for c, Sophia? If I move it to the right?
Then it's
To the left or right? If I move C to the right, C slider to the right, making it bigger?
Left?
No,
Oh, 'cause there's.
it would have been opposite if I had left it X plus C. But the X minus C lets me move, if I move it right, it moves right. If I move it left, it moves left. So this inverse relationship is taken into account by this minus sign. If I do plus here instead, then moving the slider to the right causes my graph to move left. Right? Does that make sense? But I don't like that. I want it to be more intuitive, so I'm going to have my function do that work for me. What happens if I move the D slider up?
It moves up.
It moves up, right? That one's pretty straightforward. That one is more intuitive. So plus D is I'm whatever my original value would have been, then I just add some value D to it. So that moves my Y value up or down. So this magic function is worth notating and knowing and memorizing. So you should write this down and all the definitions too. So for example, so you might see a question that asks you to state the period, the domain, the range of the function, and draw the graph. I'm gonna start by writing down all the stuff that I know. Along the way to answering this question. So can you write down amplitude, period, horizontal shift, and vertical shift? What's our amplitude? What's our period? It's not 2. Yes. Meaning it's what? How did we get that?
It's 2 pi over 2. You cancel the 2's. Or they go to
So I have to rewrite this. How do I rewrite it? To get it into this form. I need it in my magical formula form. So the 3 out front works just fine. And then I have what?
2 pi over 2 x
how did we get there? How did we get there? So this, my magic formula, only has x by itself. So as a first step, I need to deal with the fact that I don't have x. I have 2x. So how can I fix that?
Two times x minus pi over two.
Yes? So what did you do to get that?
I divided the entire thing in the.
I have to factor it out. So if I factor out a 2, that leaves what? X minus. I can't leave it as pi because when I put it back, that would be 2x minus 2 pi. Pi over 2. Right, that's how I factor it out. And then plus 1. So now I have a is what? This thing is starting to look like a period, but this thing is actually 2 is what? 2 is
pi over
2 is 2 pi over b. 2 pi over b. So this is my 2. This entire thing is my 2. So that's 2 pi over b. So what's b?
Pi.
And then what's c? Pi over 2. Now that I have it in this form, I can go straight to that. And what's d? 1. Okay, that's it for today. We'll pick it up from there next time. Thank y'all. Good job.